In this video, we are starting with the grade 11 trigonometry. The first thing we are going to do is the definition of the trigonometric ratios, which is actually revision of grade 10 work. When we look at the word trigonometry, we see three things. The first thing is the tri, which means free, then the metry, which means measuring, and the gono, that means measuring angles. So actually in trigonometry, we're going to be measuring angles of right-angled triangles. Okay, each right-angled triangle has three sides, and those three sides have each got a unique name. Okay, so let's look at the names they have. In the first triangle, we have a 90 degree, and the side right across the 90 degrees called the hypotenuse side. If you stand at one of the two other angles, which are not 90, let's say A, this is you standing here at A, and you look across to the side opposite, it's called the opposite side. The third side is the one between the angle where you are positioned, which is at this stage A, and the 90 degree angle. So that's where the adjacent side is. Okay, so adjacent is always between the 90 degree angle and the angle from which you are working. Just remember that if you were working from angle B, then the opposite side in this middle triangle, this one, would have been CA. And then the adjacent side would have been CB. Okay, I'm going to say that again. If you're standing at A, the opposite side is BC. If you're standing at B, then the opposite side is AC. And if the opposite side changes, the adjacent side also changes. In grade 9, you were taught that if you have two similar triangles, say a small one and a larger one, then the ratios of their corresponding sides would be exactly equal. So how many ratios can you get in a right-angled triangle? Well, you have three sides and there are 6 possible ratios. Each of these ratios have a special name in trigonometry. If you take the ratio of the opposite side over the hypotenuse side, which is what we have here, opposite over hypotenuse, then that would be equal to sin theta. This is only an abbreviation for the word sine theta. So we can abbreviate opposite with an O, and we can abbreviate hypotenuse with an H. So this is O over H. So sine's ratio refers to the opposite side over the hypotenuse side. The ratio of cos theta, okay, we always write cos theta. We never have the word cos on its own. It always goes together with a reference angle, as in this case, the reference angle is that one, which is theta. Cos of theta will refer to the adjacent side divided by the hypotenuse side, A over H. Okay, so tan would be the opposite side over the adjacent side. Cos is the abbreviation of cosine, and tan is the abbreviation of tangents. Okay, so now these are 3 of the 6 ratios. The other 3 ratios are formed when we take the reciprocal of the current ratio. So the inverse function of sin is going to be equal to H over O. So you take the opposite, instead of O over H, which you took for sine, you're going to take H over O. That's a reciprocal function or the inverse function, and that is called cosec theta. If you take the inverse of A over H, you get H over A, and that is called sec theta. And if you take the inverse of O over A, you get A over O, and that is called cot theta. So these are your 6 functions, which you can refer to ratios, different ratios of sides in the same right-angled triangle. Okay, so let's practice these ratios. Well, we have a triangle GIH with 2 sides given and a third unknown side. Before we start, we always have to get all the sides in the triangle's length. Okay, so we're going to say that GI square is equal to the hypotenuse side squared minus the other side squared. So this gives you 289 minus 225, which gives you 64, and GI is equal to the square root of 64, which is equal to 8. Okay, now we've got GI and we can answer any questions on ratios. Okay, so now the first question I'm going to ask is, what is sine of h? This means I have to go and stand here at angle h. This is now my reference angle from where I work. And I have to look at sine, and sine's ratio is opposite over hypotenuse. Where is opposite? Well, it's that one, which is now 8. And where is hypotenuse? It is 70. Okay. Now the next question will be, what is sine g? Sine g is now this angle. I'm going to look from there. So my reference angle is here. Sine g is opposite over hypotenuse. Where's opposite? There's opposite. It's 15, and hypotenuse stays hypotenuse. It's 17. Okay, so you will realize that you can position yourself for a reference angle. You can position yourself at any of the two angles except the 90 degrees. You can never extend at 90. So what would cos g be? Cos g would be adjacent over hypotenuse. So this is going to be adjacent. GI is the adjacent one, and hypotenuse stays hypotenuse. Okay, and the last one we're going to do is we're going to look at tan of g. Tan is opposite, which is 8, over adjacent, which is 15, and there we can work out any ratio in this way. Okay, so now we can determine a side in a right angle triangle. For this, you will need your calculator, and this can be any real life problem where you get in the first triangle ABC, we got a side 6 and an angle 50 and an unknown side. Unfortunately, we only have one side, so we can't use Pythagoras. So let's try and work out our question mark, CA. Okay, my advice is that you put the CA in the top left position. You need a ratio because we're working with trig. So the only other side I have is the 6. And this is a ratio, and which ratio would that be? Okay, where will I position myself for an angle? My reference angle would be 50 because that's the only one I got. So I'm positioning myself there. And I'm looking at CA. What is CA? Well, it is opposite. CA is opposite. And what is the 6? Well, it is hypotenuse. So what is opposite over hypotenuse? That is sine or sin 55. Now I have a real angle. I don't have to put in an A, I put in a 55. Now all I need to do is solve CA by multiplying with 6 on both sides. And then I just use my calculator to work out 6 times, and there I just press the sign 55 equals 4.91. 4.91, and that is rounded off. So I might as well make that rounded off sign. Okay, easy, eh? Let's go to a slightly more difficult one. In this one, next door, a DEF, we also have a 55-degree angle. That is our reference angle, the 55-degree angle. That's where we're going to position ourselves. And we have a 4 and an unknown side. Let's try and do exactly the same, putting the unknown top left position divided by 4, and let's see if we can find the ratio. Okay, so if we look at that, it is hypotenuse, the question mark, and what is the 4? Well, it is adjacent. What is h over a? Well, that gives me sec 55. That's slightly difficult because there's no sec on our calculator, so what do? Well, we first get the 4 away, and then we change sec to its inverse function, and we know that sec theta is 1 over cos theta because they were inverse functions. Okay, so instead of sec, I'm going to write 1 over cos 55. You multiply that out, you get cos over cos 55 degrees. And you can still do that on your calculator. And that gives you 6,97. Just going to write that here. 6,97. Okay, was that easy? Not so easy because of the sec. What would happen if we swapped around the DE and the 4? Let's see. Okay, so we have another method that we can use. We can also say 4 over DE equals. Now let's look at it now. If we stand here at the 55, what's 4? It's adjacent over hypotenuse, and then we immediately get cos. Okay, but it's slightly more difficult to get the DE on its own now. First, I must multiply both sides with DE. There we go. Okay, and then I must divide the cos 55 at both sides. So it's going to go cos 55 is equal to DE, and I'm going to get exactly the same as what I got just now, which is 6,97. Okay, you can choose which of the two methods, the red or the blue one, you want to do. In our last sum, we're going to work at an angle in a right angle triangle. How on earth do we do that? Well, in this case, we do not need three sides because we are going to work out an angle and we already have a ratio, either 65 over 35 or 35 over 65. It's easier if you take the smaller number over the larger number. So let's start like that. We're going to say 35 over 65 equals, and the angle we're working with is angle L, so we just need to work out what is the ratio. Okay, so let's position ourselves here at angle L. Let's look at 35. Well, that looks like opposite. Okay, what is 65? Well, that looks like adjacent because it's between us and the 90-degree angle. All right, so opposite over adjacent is tan. Let's now work that out on our calculator. Now that is not so easy because we can't work out tan of an angle. So this is now an equation and it works differently from the previous equation we had on the previous page where we just had to work out the right-hand side. Now we need to use a new function on our calculator, and that's the one with the tan minus 1 function just above the tan. So we're going to use this little function and we get it just above the tan. Okay, to get that function we have to do shift tan. Okay, so this is what you must remember. To do that you must do shift tan. Okay, let's see. So I'm going to press shift, then I'm going to press tan, then I'm going to press 35, then divide by, then 65, and then a bracket to close my operations and an equal sign. So this is your calculator. So these are the steps, but you're going to do on your calculator. Okay, the start part of the sum is just telling you what to do. So I'm going to say again, shift, and then tan, and then 35, divided by 65, close your bracket, equals, and you get 28.3. Now what is 28.3? Well, the angle that we're working out is 28.3. So L is going to be 28,30 degrees. Okay, so this is slightly more difficult, but it's a technique that you need to know. How to work out a side in an angle, how to work out a side in a triangle, and how to work out an angle in a triangle. Okay, goodbye.